Hello and welcome. Today I'm going to try and convince you that 0.9 repeating, which means 0.999999999, the 9s don't end, it goes on infinitely forever. 0.9 repeating actually is 1. Okay, I know it sounds ridiculous because I was one of those who didn't believe that until today I saw something really beautiful and I just want to share it with you. Okay, so I prepared 3 explanations on why 0.9 repeating is equals to 1. But first of all, let's try and understand what is a repeating decimal, what is a recurring decimal. Okay, so as early as grade 4 or primary 4 here in Singapore, we had our first taste of a recurring decimal. And that's when we learned about decimal places. Yeah. And in the year before that, in primary 3, we learned about long division. And that was the first time when we combined the two together and we did a long division, and we are allowed to add on decimal places to continue the division. Okay, so if you took 1 and you divided by 3 and you added enough zeros, you realize that, hey, this long division can go on forever and ever. It's like a loop that does not end. Okay, and what results is that the answer is going to be 0.3333333 forever and ever. Okay, and that's where we come up with a notation and say that, hey, we're just going to write a dot on top of the 3. That means that this 3 is going to repeat, and this is what is known as repeating or recurring decimals. So 1/3, which is 1 divided by 3, is actually equals to 0.3 repeating. Okay, and my first justification is going to make use of exactly this. 1/3 is equals to 0.3 repeating. So we start with this, okay, and then very simply, in the next step, we're going to prove. What I'm going to do is going to multiply both sides of the equation by 3. Okay, so if you multiply by 3 on the left hand side, you're going to get 3/3, which is equals to 1 whole, 1. And on the right hand side, you're going to get 0.9 repeating. Let me show you why. Okay, first of all, if I have 0.3 repeating, it will look something like this. Okay, and if I multiply it by 3, all right, then all these 3's will become 9's, isn't it? Sorry, let me write it this way, 0.999. There'll be no carrying over or no regrouping of terms because all of them are just 9's. Yes, and that's how we get 0.9 repeating from our first justification 1. Okay, and I know that this is an overly simple explanation, and it is also probably why a lot of people cannot accept this explanation because it's too simple. I was one of the people when I was younger. I saw this and I was like, hey, there must be something wrong with this, and which is why I prepared 2 more justifications, 2 more explanations to try and convince you. So let's look at the next one. The next one will require a bit of secondary mathematics because we're going to use algebra. So first of all, we're going to let 0.9 repeating be x. Okay, we're going to let it be x. And what we're going to do is we're going to multiply by 10. Now, if you remember how to multiply decimals by 10, it's quite a simple thing to do. And that is, we just need to move the decimal place to the right by 1 position. Okay, so this is going to be 8.0. Yeah, or for simplicity, we just write 8. Okay, so if I have 0.9999 and I multiply that by 10, then I need to move the decimal place one space to the right. Okay, and this is going to be 9.999, which is going to be 9.9 repeating. So 10x is equals to 9.9 repeating. All right. And then in the next step, what I'm going to do is I'm going to take 10x and I'm going to minus away x. Okay, so that's what it looks like on the left hand side. On the right hand side, it will be 9.9 repeating minus 0.9. And let me show you what that looks like if we do simple subtraction. 9.9 repeating minus 0.9 repeating. The decimal places cancel themselves out, and what you get is a very simple 9. Yeah, so that means 9x is equals to 9, and x is equals to 1. So you can see that x is equals to 1 is also equals to 0.9. Repeating, they are actually the same number. Okay, so again, when I came across this in I think it was Sec 1 or Sec 2, I wasn't very good at algebra, so I thought maybe there was something hiding in these equations or these steps, and yeah, I didn't really believe it. I was like, oh, maybe this is some cool trick, yeah, but maybe somewhere, there's another explanation for why this is not true. Until today, I saw justification number 3, and I thought it's really, really beautiful. Okay, so let's move on to the third and final justification. So over here for justification number 3, in order to understand justification number 3, we have to first understand a very simple theorem, and that is, if there are two different numbers, two unique numbers, say for example 8 and 9, okay, everybody knows, right, since kindergarten, that 8 and 9 are different numbers. But how would you prove that they are different numbers? It's very simple. If I can find another number that's in between 8 and 9, that means 8 and 9 are different numbers. Would you agree? Yeah? So in this case, I can just add 8 and 9 together and divide it by 2. That will give me 8.5. And since there's an 8.5 between 8 and 9, 8 and 9 are different numbers. They are different numbers. Okay? So, using this, we're going to look at justification number 3. And justification number 3 is quite simple. It's just asking how many numbers are there between, say, 0 and 1. Are there any numbers between 0 and 1? And we know that there's a method we can use. Earlier on, we talk about if you add the two numbers together and you divide by 2 and you get 0.5. So that's one possible number. Yes, but I want to know how many other numbers are there. Then you ask yourself, oh, it could be 0.1, it could be 0.2, 0.3, all the way to 0.9. But does it mean there are 9 numbers? Well, there could be 0.01, 0.02, 0.03, 0.001. Yeah, so this goes on forever. It turns out there are infinite numbers between 0 and 1. Okay, there are infinite numbers between 0 and 1. Next, let's look at maybe a smaller space, right? Maybe 0 and 1 is quite a large space. There are a lot of numbers in between. How about if we reduce that to, say, between 0 and 0.4 zeros and a 1, 0.00000001. Yeah? How about that? How many numbers are there in between? We know at least there's 1 because we can use this method. 4 zeros and a 1 divided by 2. That will give me 4 zeros and 0.5. That is at least one number between them. They are different numbers. But how many numbers are there? Is there only one? Right, there could be 0.00, let's call this 5 zeros. 5 zeros. 0.5 zeros and a 6, 0.5 zeros and a 7, or 0.6 zeros and a 5. As you can see, this also goes on forever. Right? There are actually infinite numbers between 0 and 0.00001. And finally, let's look at what we're really, really interested in this video. What are the numbers between 0.9 repeating and 1? Okay? And of course, we should use our go-to method. That is, if I add 0.9 repeating and 1 and divide it by 2, what do I get? Now, in the numerator, you're going to get 1.9 repeating divided by 2. So what is 1.9 repeating divided by 2? Well, we can do long division. So that's going to be 1.9 repeating. That's many, many 9s. And we divide it by 2. Okay, we're going to start with a 0 here. Okay, then this is going to be a 9. 9 times 2 is 18. You subtract that, you get a 1. You bring down the next digit, 19. So we're going to do 9 again. That's 18. And you find that, hey, this looks familiar. This looks like a recurring decimal. And our answer for this division is 0.9 repeating. Now, this is a bit strange because this is not a number that's between 0.9 and 1. In fact, it is the first number itself. So what does it mean? Yeah, let me give you a meaning, what that means. How many numbers are there between 2 and 2.0? I know this is a silly question because they are the same number. But if you're to do this, 2 plus 2.0 divided by 2, and you get back the same answer, 2, this seems to suggest that there are no numbers between them because they are the same number. And over here, we have the same results. And that is, if you add these two numbers, 0.9 repeating and 1 together, and you divide it by 2, you get 0.9 repeating again. That shows that these two are indeed the same numbers. Yes, and I find that this is a very beautiful proof, a very beautiful explanation on why 0.9 repeating actually is equals to 1. Yeah, so let me know which is your favorite explanation down in the comments below. I hope you enjoyed this video as much as I enjoyed making that, and I hope to see you in the next video. And until then, catch you on the flip-flop.